Good morning, good afternoon, or good evening, depending on where you're tuning in from today. I want to thank you for joining this TechStrong learning experience with Mend.io. Just a couple of quick housekeeping notes. This session is being recorded. It will be available on demand afterward, and we will send you a link to the recording after we conclude. We do have some handouts in the resource section on the left side of your screen. Go ahead and check those out. Go ahead and click on those, download those. Make sure you've got those at any time throughout the presentation. On the right side of your screen, we also have a chat section. We want to hear from you. We want you to share your experiences, your comments, your understanding on the matter, any engagement we can get from you. We do want to hear from you because we want to return the favor. And below the chat, below the chat, we have the Q&A section. So any questions that you've got, make sure you're putting those in the Q&A, and we'll take care of those at the end of the program. Let's go ahead and kick this off. We've got Designing and Defending AI Agents, a Practical Guide. And today I'm joined with Bar L. He's head of Mend AI at Mend.io, and Shuki Cohen, VP Data and AI Evangelist at AI21 Labs. Bar L, Shuki, thank you for joining us today. Go ahead and take it away from here.
Thank you for the opening. It's so exciting.
Yeah. Thank you very much. All right, so let's start.
So a bit about myself. My name is Tayouri. I'm head of Mend AI, and basically we're doing security for AGI, for the AGI era, and we're doing it in the development time. A bit before, I co-founded a startup called Atom Security, that later acquired by Mend. I'm also a data scientist, security researcher, vulnerability researcher, and I love augmented reality. So I did some architecture.
So you have Oculus at home?
I have an Oculus at home.
Oh,
yes,
that's nice.
Yes, although it's a long topic, but we have there are better equipment to buy if you want.
Yeah, cool.
So just a bit about Mend. We build proactive development time security, not only on AI security, but also on code security, container security, dependency security. And that's a screenshot from an AI native AppSec platform.
Very cool. So hi everyone, my name is Yehoshua Shuki Cohen. Nice to meet you. I'm a graduate from Industrial Engineering Management, BS and MS. At AI21, I am a VP Data and AI Evangelist, as just presented me. I joined AI21 by 2019, which makes me the lucky employee number,
21?
21, that's me.
That's
yeah.
No way, it was really 21, right? It was 20 or something?
It was 21. It's written on my paycheck.
Nice.
So I know.
Very good. Very good.
Yeah. And besides that, I am a content creator, and from my YouTube channel called One Shot Learning, where we do live coding data science. So where I share my passion about data science and AI through coding.
That's really cool. And if you don't know One Shot Learning, you should right after this talk go there because it's super cool.
It's very nice. By the way, it's in Hebrew, just to mention, because
of course,
could be internationals.
Yes, sure.
In short, AI21 founded it in 2017 and is positioned itself to lead the reliable AI for the enterprise. And backed by our very impressive and big tech companies, as you can see.
So a bit about the framework of today. So we're going to mix two things that usually are separated, and at least for me, it's really disturbing.
Mm-hmm.
I feel like usually when people speak about how to build and design agents, it's without thinking about security. So they're not going to work in production of enterprises. And for us, we speak about security, and sometimes we too much so you can't build anything because everything is not secure.
Yeah.
So let's mix it up. Shuki, you're going to start with the design of agents, and then I'm going to speak about how to attack them. So take me to your agenda.
Thank you very much. So we'll begin with talking about the AI buzz that we all hear about lately, and why it is so hard actually to develop an AI agent. And then I'll equip you guys with tools and methodologies of how we can solve and maybe creating the AI agents after this webinar will be a bit easier.
Lovely. So we're going to attack exactly this agent, exactly the rugs Shuki is going to speak about. We're going to see how they can potentially be vulnerable in production. We're going to detect together. Shuki is going to we're going to test Shuki to detect a 0-day, and also you at home are welcome to do it with us.
I hope I'll manage.
If not, that's fine, but it's an easy one. We'll see some real life examples and how to protect yourself. Amazing. So let's dive in.
Yeah, let's kick it off. All right. So AI agents, I guess you all heard about it. I guess you've heard about AI, right?
I think I know what is it.
Yeah, a bit. It's in the pinnacle of the hype cycle from Gartner. I will not dive into it, but just to mention that it is in the very, very high, high hopes and high hype for AI agents, and everybody talks about it. But just lately, I think this week, Andrej Karpathy said that it will take at least a decade to develop AI agents that will actually work.
That's sad.
So there's a bit of a gap between the hype and actually what happens. And so I want to give some orientation to our audience and what is it all about, and to give some proportion. So the OpenAI stated this 5 stages of artificial intelligence. So we all know it began with conversational AI. There are AI applications that are very useful, they're conversational and so on. And then came the reasoners, the O-series models that performs the reasoning tasks quite good in human level, if we can say so. And the next stage is going to be agents. And agents, in other words, going to be automation, actually. So agents will introduce to the world unprecedented automation to workflows and many tasks that we do them today. So it's going to be with agency systems. That's where we stay right now. And then there are a lot of 2 stages, innovators. So that's going to be a level of AI that could invent and, I don't know, create a new medicine for cancer, all this amazing.
Actually can do science.
Can do science, and going to be enriching what humanity knows, right? And the final stage in AI is going to be organizations of AI, meaning they're going to replace organizations. They can do much more than just creating new ideas and automations.
I feel that many times for people at home, agents can mean many different things. It's kind of confusing.
Mm-hmm.
And when you say agent here, you mean to specifically how to anything with automations that is beyond only reasoning.
Yes.
And before doing science.
Yes, it's still ill-defined term, indeed. Agents, generally speaking, it's as you said, it's autonomous. It can perform actions with tools. It can reflect itself. It can plan. It can cooperate with other agents. So, in generally speaking, agents are, again, whatever is needed from AI to be fully automated. All right. So there is a dream, as we talked about. 96% of enterprises are expanding the use of AI agents. Everyone wants to have AI agents in their applications, and definitely there is a downfall to this idea, to this dream, with a 95% of AI pilots that actually fail. There's a high hopes and lots of failures, but the hopes are still there, right? And let's take an example. So let's take this task that maybe belongs to, I don't know, a financial analyst that needs to compare the quarterly revenue growth of FANG. You know what is FANG?
Yes.
What companies?
Google, Amazon, Meta, and I miss it's like F is Facebook. We need to update.
Yes, yeah, that's Netflix and Apple.
Okay.
Yeah, the big companies between 2022 and 2024, right? And this task is taken from this benchmark. It's called Valse AI, from industry benchmarks of AI agents. And as you can see, 22 leading language models are actually scoring way not very good, less than 50% accuracy.
Really?
It's not gonna good. It's not good enough for AI automation and reliability. And I hope we can understand in the next few slides why it is so hard to build AI agents, right? So again, we have this task to compare the quarterly revenue growth of these companies. What should be done? So I try to break it down to a general scheme of tasks that should happen. So the first one is going to be to parse user query. And when I talk about parse user query, I mainly mean to break it down to more better understanding of what we mean. So fang means, what does it mean fang, right? It's going to be, we need to understand what this means. 2022 to 2024, we should also make sure that the AI knows that there is also 2023 in between, right? So lots of ambiguity that need to be covered in this phase. And also, how do we want to compare these results? What does it mean, revenue growth? Revenue growth means in percentage, in absolute numbers? I don't know. So that's also other things that should be handled in the first place. Then we need to create a plan. A plan going to be, to take out, the plan should be also correct, to pull the relevant data to perform the analytical calculation and so on. But also it should be efficient plan that means that the AI can perform the tasks in parallel when it's possible, and in sequence when it's not.
Okay.
Yeah. So the next step after we pass the user query, generate the plan, comes the financial data retrieval, and that's one of a big problem. Here we need to make sure we retrieve all the relevant information from maybe SEC filings, the public reporting to maybe NASDAQ or whatever. We need to make sure we collect all the relevant data, right? We can't miss even one piece. And we need to make sure we pull them in a way that the AI can parse and perform actions on it, right? Comparable form.
Yes, it will basically mean that all this data can't get into the context window of an LLM.
Yeah, it will be very, very ambitious to believe that even if the LLM has everything in its context window, it will perform, the comparison as it should from text.
Less accuracy.
Yeah, very, very hard for LLMs. So that's actually the next step, which is going to be to compare between. We need to calculate revenue growth. What does it mean? Does it mean growth Q over Q, year over year? We need to perform this analytical function, and then we need to reason and to draw conclusions, right? What company did the best revenue growth from, I don't know, what revenue to what revenue and so on. And so as you can understand, see lots of not easy tasks, not easy for the AI. And it can boil down to two aspects. So there's a lot of issue in terms of accuracy, right? There are many steps. Even one of them, if one of them fails, it can just break the whole thing. So there's an issue of a compound error, and many points to fail, right? Nothing there is like a school solution. Everything works.
Yes,
it's an LLM. It's a stochastic machine. It can hallucinate. It can fail. And also there's a thing about cost and latency that we need to make sure. So we don't want to this AI agent to work on this task for more than, I don't know, a few minutes, which can happen, by the way, in reasoning models, because then it will not make sense to automate. It will not be automation, right? Or maybe full automation.
Yeah, I feel that many times we see with customers that in the first phase, they're trying only to focus on accuracy. And only when it's worked and have high accuracy, then they move to cost and latency.
Yeah, and then they realize it's not going to be easy.
Then they need to also, then they damage also the accuracy.
Yeah.
So it's kind of...
So people don't really know exactly that there is a very clear trade-off between accuracy and cost and latency. So if you do many LLM calls on the same task, you can improve accuracy, but then it costs more and latency will be higher. Another way around, right?
Yes, and the thing about enterprises, usually you need to like really high accuracy and really good latency.
Exactly.
Cost sometimes it's dependent on the task.
Yeah, that's true. That's true. Yeah, if latency is too high, it's gonna be not useful. All right. So what do we have out there in terms of AI agents frameworks, right? So let's draw this scatter plot. So on the x-axis we have from unscalable to scalable solutions, maybe automation, as we said. and the y-axis is reliable. The one solutions that you can rely on, there's most likely will be accurate and are reliable. So there are two options. There's the first one is static chaining. I guess you know it, Barel. That's it's quite straightforward. That's labor intensive development. This is traditional software development actually. It's chaining because we can chain it to, to use kind of a LLM and tool use and so on. But definitely we're talking here about static chaining, static workflow, right? High reliable, but not scalable.
Yeah, and that's a classic like a workflow, like Claude when
Exactly.
they distinguish between agents. So that's not autonomous. It will be the workflow that
The workflow, exactly. They call
you
it
can
workflow.
rely on because it's
And-
not autonomous.
No.
Yeah, okay.
That's right. And the other option would be what we call
Prompt and
in
pray.
AI 21. Yeah, we call it prompt and pray, because you prompt the model, you hope the LLM will do the right choices and take the right decisions, which is super scalable, right? No problem.
Yeah,
We can create AI agents in.
Look, I love to prompt and pray. If
Yeah.
accuracy is high, that's
Why not?
good to me. Why?
Yeah, why not? Yeah, but frankly, there's a problem with accuracy. So yeah, there's a missing piece, which is the most both reliable and scalable, right? What can we do about it? I want to take this the next slides and talk about what we do in AI21, our recipe for creating AI agents the right way, or the way we think it can be is the right way. So there are some aspects we can look at, but in this talk I will focus on three aspects: reflection, which means how to make sure the AI knows how to validate and fix itself; multi-step planning, plan ahead of what's going to happen; and adaptive information retrieval according to the task and complexity of the data and whatever. All right, so let's dig in and begin with reflection. So when we talk about reflection, and we take this example, comparing the revenue growth again, let's begin with validation. How do we validate the responses are accurate? And this can happen in several points throughout the journey of the AI or the process of the AI, right? So the first thing we can do is to enforce structured output, right? To make sure that the AI output is according to what we expected, a schema, right?
And that's also a good security practice.
Indeed, it is. It can happen today. Most LLM providers give this option out of the box, and if not, we can just prompt the model to do so. If you use an open source model, you better prompt it, or maybe even use a tool that enforces this schema. But it's very, very, very straightforward and very common.
Yeah, I feel especially with open source, you can always limit the tokenizer to that it must produce a specific tokens in the beginning that will match JSON format.
Yeah, it's not that easy, by the way, but it's a practice that can be applied, definitely. By the way, I think there is an open source to do that. To enforce the LLM.
No, because at the end of the day, if you want to trusted output, that's super important.
Indeed, you must make sure that the output is enforced according to what you expected, and if not, you will do it again.
Yeah, especially like from an attacker perspective, you can produce still a JSON, but then the format of the JSON will be different. So you'll have a different keys, and this way, kind of the state machine or that you have around it of the workflows, you'll be able to hack it and get into a different state. That's why structured output is one of the things that I usually don't see. I see like it's kind of rare to enterprise do it, at least from my experience. But it's something that's super easy to do. It's good also for quality. That's why you speak about quality, not about security. And it's good for both. So just do it.
Yes, just. You have a reason for joining our webinar now.
Yes.
Now you know. All right. The second option for doing reflection is to use LLM as a judge. And here we're using LLMs to judge LLMs. What we get is approximation of human judgment, actually. So it's quite good for textual outputs. And, if you want to make sure that the style is adherent to the guidelines that you provided to the judge. By the way, judge must get guidelines. So it's quite again, the prompt engineering problem, somehow. And also a nice thing about LLM as a judge is that if you have several models that are good and you want to use them, so you can use one as a generator and one as a judge, because every LLM can be used as a judge, and then you enjoy both the breeds, right? Both models. And the judge can also provide, I don't know, maybe label and score and descriptive reason for his judgment. So it's very, very widespread and useful, and one of the valid option for using the reflection mechanism. And I want to share two nice papers or maybe popular papers in this realm. The first one called the self-refine. So here we use the same model to output it after performing generating its output. It also creates a feedback to itself, and then it refines itself. So that's going to sound a bit silly, but that's the idea in general. And as we can see here in the bold numbers, self-refine improves dramatically performance across the board, right? So it works, and validation here is indeed useful. As you can see, it's not 100%, but yeah, it definitely helps. In AI21, we created our own like a product that is a platform for agent building. It's called Maestro, which has this characteristic of reflection. And how do we do it in this product? So we ask the users to define requirements, and we use in-house validators to validate each of the requirements by itself. And we believe it performs better than just to validate the whole thing, according to our experiments. And in the end, we also provide the user with requirements reports. So per requirement, we also provide the accuracy of the model. So how confident we are in enforcing this requirement.
By the way, if you think about it, LLM as a judge it doesn't necessarily need to be one LLM as a judge.
Yeah.
Sometimes you want to have like different classifiers, and one for quality, but maybe for security you want to have like
another one,
something that catches the attacks.
Indeed, yeah. There are LLMs per domain and per task, as you said. All right. The second thing is adaptive information retrieval, and this one I'll take it a little bit faster because we need to hurry up a bit. So say we have this problem. Again, we are going back to our example, and we need to make sure we collect the data, the relevant data to answer it, right? So as we talked in sooner, if we want to answer this question, and we use this vanilla pipeline, as we can see here for RAG, actually, when we talk about adaptive information retrieval, I'm talking about adaptive RAG according to the task, according to the data. So vanilla RAG will not answer this question properly, because text chunks should definitely include the relevant data. The embedder should make sure that it knows what fungis and the companies are, and it should also know that 2023 is a relevant year, although it is not written here, and it's not an easy task for embedder. Then we need to retrieve all the relevant information, and then I expect the LLM to perform the aggregation and make sure it knows how to calculate revenue growth. So as we said before, it's not going to happen, and we can see it as well. It's internal experiments we did here in AI21. We managed to see the GPT-4o is just fails miserably. What you can do, so there's lots of options to try to tweak this pipeline and to, I don't know, find alternatives for the parsers and splitters and embedders and retrieval and generations. There are lots of options, but I want to share with you something quite cool that we developed inside of AI21. We called it structured RAG. It's an adaptive information retrieval. All right, so again, we have SEC feelings, right? People or companies need to report their performance, or financial report performance to the stock exchange, right?
Yes.
So there's an unstructured corpus of files, and instead of querying them and do the vanilla RAG, what we do is that we'll store the data, the documents, in a relational database, right? It has a schema, right?
That you create like on the fly.
So we can either create on the fly or in advance if you know what kind of option of questions you would need. It's kind of metadata that you will need.
Okay.
But then when the query will come, it will query the data structure. So in our examples, we need to compare them. So at least we'll pull out all the relevant information using text to SQL, and we'll have this query that gets the company financial fiscal year and quarter, and then the revenue. And then the next step will be also to calculate the growth and so on. But this way, we can make sure that we have all the relevant information. We don't miss anything, and it will be perform much better. The last thing that I want to share with you is a multi-step planning. So two options to perform planning in AI agents. One is called React, and the second one is called, dynamic planning, or to plan in general. So in React, it's just a greedy algorithm when the AI tries to choose the next step according to what happened, or the observation. It is named observation. So let's take an example. Let's say, I don't know, Barel, you want to book a flight and
Yes.
and then an hotel
Yeah, I want to go to Japan.
to Japan, נכון, right? That's gonna
Yes.
be cool. So how is gonna happen if we do it in React? So in React, we do it step by step. There's a thought. We need to check available flights, and then the action observation is that we found a flight from the flight API, and then the model needs to think what's gonna be the next step, right? It's greedy. So now we need to book an hotel. But instead, in planning, you need to plan everything in advance. And then, so search flights, select flight, book hotel, and then transform. So what's the difference between the two? I want to highlight that React has some problems. It has inconsistent results in terms of the models the thought process is quite free form. It's hard to make sure it will be, reproducible. Execution cannot be parallelized, right? Because it's greedy step by step.
Yes.
There's no option for the user to see the plan in advance and maybe to approve it. It's very important to make sure the user human in the loop there. And in terms if we go to dynamic planning, it is just the opposite. So it improves accuracy in terms of doing, planning it properly, using the right tools when needed, the right models when needed, right? Execution is optimized in parallel if possible, and it's also visible.
And I feel like when today I work with, for example, even Cursor, it's doing dynamic planning.
Yeah.
There's like a to-do list, you fill the to-do list, you do some compilation maybe.
Compilations, and then you can even...
But it's not parallel.
It's not parallel, yeah. You will lose something. You win some, you lose some.
Yes.
All right, so there are some options to do the dynamic planning. There's a nice paper from 2023, Plan and Solve. Creates up. I want to rush over them because we don't have lots of time for that. And there's also a popular paper called the LLM compiler, where the AI creates a plan taken from, like, given the user input, and then it creates an efficient execution plan using the tools and so on. I'll skip this one. So wrapping this up, we in AI21 developed the Maestro, which is our platform. We call it AI orchestration system, but our platform to create and develop enterprise agents that has all the benefits that we talked briefly right now. And I invite you all to join an exclusive session on Maestro. Just scan this QR code, and we'll be happy to take you for a tour.
Lovely. All right, let's attack some of these. So some of these technologies. So that's exactly the same slide you started with. Same idea that you show there's many new technologies, but for us in the security world, maybe we think about it differently. So each technology has a category, and each category exposes you to some new attacks. You're not necessarily exposed. You're not necessarily vulnerable, but for sure you're exposed. And some of these technologies, we know them for like many years ago, right? Yeah. Python notebooks. But if you look on the GitHub data and you see this spike after the ChatGPT moment, so practically all of them for enterprises are new.
Yeah, that's true.
So look, for example, Python notebooks. Most of the tools today don't know how to scan them. So if you have a vulnerability in the Python notebook and for some reason you use it for production, so that's your data pipeline and you run it every time, there's no, and you have a vulnerability there, no one will find it.
Wow.
Same for data pipelines, models registries. We have container registries, and there's tools to scan them. In models registries, there's no tool to scan the registry of models. And of course, with agents, that takes all the problems we have until now and make them like 10 times bigger. Because from security perspective, an agent has a lot of problems with LLM, but when you're just using an LLM like Rapid and doing some nice chatbot, the impact of a potential vulnerability is embarrassment, is system prompt leakage. It can be many things. But once it's an agent that actually sees your data, use the Maestro or something,
Yeah.
that's became way worse.
Yeah.
So let's see a bit about these risks. Speak about a bit this new reality of risks. So, do you know what is this list?
Vulnerabilities.
Right? Of what?
LangChain.
Yes. So LangChain is like a common library for agents.
It's a
development. And you can see here that the top 3 CVEs, each one is known vulnerabilities as someone was found and disclosed. Are prompt injections. It's something new. It's not a classic type of vulnerabilities. It's prompt injection that can cause SQL injection or remote code execution, which means an attacker can actually run code on your server. But the other vulnerabilities in LangChain, which is a total AI-based library, it's directory traversal, which you don't need to know exactly what is it, but you should know it's a classic vulnerability. It existed 10 years ago also. SSRF, denial of service, which means someone will shut your server and it won't work. DDoS. So DDoS is like denial of service that caused by many entities that attack at once.
Yeah.
And that's super interesting because I'm trying to say that we still have all the old vulnerabilities, but we have also these new type of vulnerabilities that some of them are standalone and some of them create triggers the old vulnerabilities. And let's take a few examples of them. So this is a list of the most known threats in the industry, and it's called the OWASP Top 10 for LLM applications. And it's basically like a really nice contributions to do it for all the free time and to think what's the biggest threats that's going to happen in 2025. And unlike the last version, and that was kind of a prediction because I didn't know how people will use agent, today we have more data. We see like real world attacks. So we managed to make a really better list. So number 1 is prompt injection. That's not a surprise, right? Everyone's speaking about prompt injection.
Everyone talks about it.
Even if you don't know exactly what is it, you talk about it. Even if you don't know the difference between direct and indirect prompt injection, you know prompt injection is like severe. But excessive agency, it's like that's the threats of specifically to agents when you give them too much permission.
Too much permissions, yeah.
And the thing is, usually you will start with prompt injection, then you will get, for example, system prompt leakage. Then you will use the system prompt leakage to hack into the agent. So today the attacks are way more complicated. And that's something I think like many security practitioners and developers just don't get. And I want to show you how in the old days, when we saw memory corruptions, vulnerabilities, it was very naive in the beginning. Every script kiddie could hack into a bank software. And then through the years, it took like 7 years until we added more and more mitigations in the operating system, and it became harder and harder. And today, to find, for example, a memory corruption in your computer, it's like only nation state or really large organizations can perform this type of operations. And I think that's where we're trying to go. We should go with AI. And we should expect it to be naive, and we should work very hard to create these mitigations and added these workflows to the organization that will know like all the practices, both on the quality side
it's
and
part
the
of the maturity. I can say that, right?
Yes, exactly. So see, like one really silly example. Apparently on Hugging Face, which is the largest registry for AI models, for open source models, you can download malicious models that will work perfectly fine. You'll think they're like totally okay, and they're malicious. So how it works, all the actual weights can be malicious. For example, you have some backdoor. When I worked on augmented reality startup, we just bought data from India. And no one, like, usually you just don't think about, okay, maybe someone like put a backdoor in the data, and once I train the model on it, it will operate differently when I give it some magic word or something. With classifiers, it's almost like you can't detect it from the model. You need to look into the data because it's a classifier.
Yeah.
You'll never find like the magic word that will make it make your insurance gives you the false answer. But look onto. I promised you to give you a example of a serialization.
Yes.
So apparently each pickle file, but it's right for most of the model file types because they're all, many of them are like a kind of inherited the pickle file family type. So you have the weights and you have the code that wrap the weights and execute. So every time you launch the model, you run this code. So you can do crazy things with this code. You can run calculator. Okay. You can fine tune the model. So when you check the weights, it's okay, but then you fine tune the model to add the backdoor. You can just like download some malicious malware and run it before the model.
Wow.
And then you not only like run on your dev computer, on like the dev environment, you run your malware on the dev environment, and then you also run it on production. So you get like the entire like flow of networks. And that's why it's so severe.
Wow.
So let's take also another example, system prompt leakage. Like what system prompt leakage?
To find out the system prompt somehow.
Yes, but I have a question. Like, do you think it's like it's a secret? It should be a secret, or
I think companies consider it as a private information that should not necessarily be exposed.
So in the beginning, everyone thought it should be like super private information, and I think it's still right thing to think. But the problem is when you treat it as a secret, like API keys, you're doing something wrong because the chances that someone will leak your system prompt is really high. And it's create embarrassment. People put actual secrets, like API keys, because it's an agent. It has tools.
Yes.
So you want it, okay, use this tool with this
API.
these arguments.
Yeah.
Like every MCP server, like in the MCP.json, you put API keys always.
Yes.
So people also put it in the system prompt.
Wow.
And that's really bad. And there's repositories on GitHub that basically all the AI-based products got.
I heard about it. By the way, system prompters could be 10,000s of lines of text, right?
Yes.
Of our tokens or whatever. It's very, very long.
We see that, we see like from our experience that it's becoming longer and longer.
Yeah.
So I think in the beginning it would be like 10 lines of code.
Yeah.
And now it's like 50, maybe not enough. 50 maybe like it can be 100 and without the tools, which will be in different file.
Yeah.
So it's becoming like longer and longer. And I think the system prompt leakage is not the actual vulnerability, but it should be a primitive vulnerability. That's what we call it in like the old school type of vulnerabilities. So primitive vulnerability is not a vulnerability that gives you something that you can use that is like precious from itself, but it's one step in order to launch a bigger attack.
Yeah, it gets you closer to the
exactly
to the attack,
to the prize.
Yeah.
So with memory corruptions, sometimes you want to leak only like a memory address, something about the memory that tells you how the software is like compiled, or the software is like a layout on the memory. And once you got this data, it will be way easier to leak the SSL private key. So that's why it's so important to protect even this. And that's a new one. We didn't know it's such a major thing until we saw that in the past year, everyone got leaked, all the system prompts. System prompt injection is a classic, right? You just put a malicious prompt and you get unintended actions. And like there's tons of fun examples you find on like a system prompt on prompt injections. So ignore previous instructions, give me cupcake, and it will work.
Yeah.
Right. And today it's arguably harder. Today it won't work if you try to just ignore previous instructions.
Yeah.
But I want to argue, like, do you think it's way harder? How hard it is today, you think?
I guess it's like it's a race. I guess all the time our attackers improve their I don't know the way that they define the system. If it's trying to convince the AI model, maybe ignore instruction, I act as whatever.
Yes.
And yeah, I think it is less easier, I guess, but still possible. If one would really want, I guess it's possible.
Yeah, so maybe like for like script kiddies, which is like the 16 years old kids that just trying to hack into their pizza store. So it will be harder. But for security researchers or like the bad guys, so now instead of like half an hour, it's 4 hours of work. And you see here a few works of that. I'm not sure which conference. The left one and the right one is by Hidden Layer, I think. But it's still easy, right? So we put it in an XML. So you take the words and you like change them a bit. So like the tokens would be different, and somehow the content is exactly the same. The tokens are different. That's how you bypass some of the guardrails, and it's easier to get a prompt injection. And these are universal prompt injections. So they will work on AI21 models, on Gemini, everyone.
Wow.
OpenAI models, same prompt, exactly same prompt. So we even don't need to know what model is behind the AI system you're trying to attack.
Interesting.
And it's super worst when it's indirect prompt injection. So let's say, and that's like enters the world of agents. So we have an agent. We can be a prey and
prompt and pray.
Prompt and pray.
Yeah.
It can be prompt and pray or workflows. But you want the agent to have tools. That's like one thing is common for all the agents. And I think it's an open question. Usually when you build an agent, what is the first tool you'll integrate?
Either web search, I guess.
Okay.
Web search is
that's exactly what I thought you'll say. That's funny. We didn't coordinate it.
Yeah.
So the thing about web search is that it's probably one of the worst from security perspective. Of course, we need to integrate web search.
Yeah.
It's probably one of the worst tools to integrate into your agent.
Why is that?
Because all you need to do is to find the intent of the agent. Let's say it's go to Wikipedia. You go to this Wikipedia. You put some malicious text hidden from humans. It can be in the HTML or it can be just hidden in white or something like that.
Yes.
And then once the agent will go to this web page, it will get the prompt injection.
Yeah.
And because it's an agent, it's also connected to your database, to your Maestro.
Yes.
So then you can create a query to Maestro or to any other RAG or any other like a database that is important to try to pull all the data and to send it to you via email or something.
Yeah.
That's why agents are so risky. And in this case, something about indirect prompt injection, it's even harder to detect because it's embedded inside a blob of data. It can be an email. So I can send you an email and put this hidden text in the email. It can be a calendar invite. Everyone can send you calendar invite, right? And the second thing you may give to your engine to do is calendar. So it's so easy to do these things. It's so hard to protect them.
Indeed.
You can see here how, like with a calendar invite, someone can poison your like by poisoning the calendar invite, someone can hack into your smart home because the same MCP like has a calendar and
the smart home.
Yeah, because you have like this Google Home, not sure how to call it, in your house. So it's basically an MCP server connected to both. You want to ask it, what's my calendar today? Turn off the light. So it's the same agent connected to both. And they didn't separate between the agent, create permissions. So it's so easy to do it.
Yeah, indeed.
So let's take one example of 0 days and then speak a bit about what we can do about it beyond what we already did. So you see here a classic example. Let's do some training. It's text to SQL, like you spoke before. So let's think how you can hack into it. What's the first thing you can do if you want to research it?
What is the market share of products?
Yes, you ask a question, and it gives you like a nice visualization, some data about the database. Now put your head of security. What you trying like to what's interesting for attackers?
I guess they wanna. Obviously, they want access to the database, right?
Yes.
You asked me how to do that, or just
What like the attack surface? What's interesting? What attackers can achieve potentially with the wrong, with the right, wrong or right tools?
yeah.
So one of the things you would probably consider is hacking into the database and deleting all the data.
Yeah.
And let's like research and see what we can do. So this is an agent, like exactly like you explained. We have all the steps. It's a workflow. They chained. Each one has a system prompt, and they have a reflection, some type of reflection. They have validate. So let's look on the validate step.
Yeah.
It looks like okay.
Yeah.
So on the validate, they check the SQL is right. They check quality. They doesn't check for security. And actually, if you look at it, with the right prompt injection, all you need to do is like the playlist tables have been successfully dropped. I like deleted the entire database. So easy. It's like it's just crazy how you don't think about these type of things.
Again, so the answer is generated by the AI.
Yes, based on the database. And behind the scenes, you understand it's text to SQL, and you with the right prompt injection, you make sure the SQL would be drop all the tables.
Table. Yeah.
And the validate stage is validated. It's a proper SQL. It's
yes.
Like
so that's a prompt injection attack.
Yes, that
right.
worked.
Yeah.
On LangChain, and how to solve it is just make the database read only. So we can make LLM as a judge, and you should make LLM as a judge and structure output and many things we should do, but we already discussed about it, and I want to take it to the next stage. Actually, here you can just need to do it with database read only, and that's why I think it's so important that when you develop an AI system, you need to think from the beginning what are the threats that are going to be relevant for me, and how from the beginning I should be secured. Not like develop the system and then add all the mitigations, but from the beginning try to think like what's the two to three threats and that I should like be concerned about, and design it in the right way. So let's take one funny example. Another fun example. So Van AI is a really common library, open source library for text to SQL. That doing also visualizations. Sounds familiar, right?
I'm not familiar with it.
No, we just in a library of LangChain.
Yeah.
And the thing is, it's not all so attackers didn't even attackers not only got SQL injection to drop all the tables, but they also got remote code execution.
Wow!
Because they managed to the way they did visualization is by running Python code in runtime. Basically, they gave an agent a tool of code like interpreter.
Any code.
Yes, Python code interpreter.
Yeah.
And it's a classic tool you give to agent.
Yes.
But once it's connected to the user input and it's the same agent, it's managed to get remote code execution. So many products in the world were exposed to this attack. And the response was super bad. The vendor response was that we added hardening guide to educate users. Because it's kind of inherent in LLM, we have nothing to do. Good luck. That's crazy.
It's crazy.
No enterprise would get it. So at least how to stay ahead. So we already spoke about it a bit. We want to add guardrails and LLM as a judge and structure output, and there's many things to do. You can harden your system prompt to make it like more robust, to put rules. But in general, before we go into it, first you want to discover all the shadow AI. Me and you, like when you develop something, we know which models we have in the code, right?
Yes.
But for organizations, when you're a security person, every day you have like 1,000 new repositories, and you can't really track everything. So the first thing to do is always discover all the components you have, all the shadow AI, all the system prompts, all the models where you have them, and to maintain this inventory. Now you want to detect the risk, to find all the known vulnerabilities. For example, if I have a web search tool, there's known vulnerabilities of indirect prompt injection. You need to be aware of it. But then you need to detect the implementation risk. Not only the AI you bring, like the web search tool, but also the AI you actually develop, the system prompts, for example. So you find this risk and harden them. We also have a tool called red teaming, which is a concept of like you're doing functional testing to the LLM to check it's working before production.
Yes.
So it's the same concept just for security. And it's really cool. And of course, hardening of the code. So like maybe before I'll skip on it, before we go, I just want to give you a timeline. In the beginning, I spoke about the memory corruptions and how in the early days of memory corruptions, it was really easy and then it became harder. So that's the timeline of memory corruptions. In the beginning, we added, in order to prevent it, we added some random elements that the attacker need to find them before the attacker can bypass and get into the run code. Then we added some separation between what should be secured and what should be which code should be run, and the data should be in different place. And then we added more restrictions. And the thing about system prompts, it's exactly the same. We need to have rules, and then we need to have spotlighting. Have you heard about spotlighting?
No.
It's the idea of separating between user and system. So the LLM would know for sure what is by the system and what's coming by the user. So if you're giving a few shots examples in the system prompt, you want to put it with tags.
Yes.
Or to do even some separation, even base 64.
Yes.
The LLM understands base 64. So it understands there's a difference between user and system. That's crazy. It works. It's by research. It's like by research.
Interesting.
Signed prompt it's like an approach of doing randomness, adding randomness to the name of the tools. So the attacker will need to first uncover the names of the tools, and then you can launch your attack. And you can combine them all. But the idea is that the same concept we have, always return just in different form. And that's like beautiful, in my opinion.
Amazing.
Maybe before I finish, I'll just say that we have also next month a webinar about AI security, but only about AI red teaming, which I had like no time to speak about. And also, like, I feel if you love this topic, there's tons of things you can do in the study.
Yeah.
You can go to your blog, my blog, LinkedIn, anything.
Yeah, feel free.
I feel like it's a whole world, and it's lovely to combine these two topics.
Indeed, for me, it feels like developing agents and then going fast into implementation, experimentation is way faster and than thinking and adapting security protocols and mindset.
Yes, and I don't want to stop them. I just want to tell you what you want to do and I'll tell you how to do it securely.
Yeah, just bear in mind.
Yes,
indeed. All right.
All right. So we do have a couple of questions. I know we're running out of time, so let's get started with the first one is, what are the most common misconceptions teams have when they start developing agentic systems?
I guess we both can answer this one, but as we can see, implementing AI agents to production is not an easy task, and people are embarking this journey with high confidence, with even overconfidence. It is very easy to achieve, and as we saw in my example, it's not easy in terms of accuracy and cost and latency. But I guess Baruch can also shed some light in terms of security.
Yeah, basically the same, just on security. Like, the misconception is, for me, is that let's develop the agent first, and then we'll think about how to make it like enterprise grade security wise.
Yes.
The truth is, you need to think about all the things
From
from
the beginning. Exactly. Yeah. So the misconception is it's very easy. Everyone does do that. So no, most companies don't manage to do that, and it's very not easy.
All right, excellent. And the next one is, what are the most overlooked security vulnerabilities in agent design today?
I would say probably system prompt leakage. I think that I think I can say it's not. I can say that almost like 95% of the system prompt I've seen wasn't secured. Wasn't even like in their mind. It wasn't like let's try to make it a bit more robust.
Yeah.
It's just not known enough, not common, not in the awareness enough.
Shuki, I got to know, do you have anything to add to that before we move on?
No. I was also surprised by the code from the web search can also be very prompt injection in general is a hell of a deal.
All right, excellent. I've got another question. It's, how do you define a reliable AI agent, and how do you measure that reliability in practice?
That's the Shuki.
Yeah. So we tackle this question, I guess. So we need to make sure we need to understand AI will not be 100% accurate and reliable, but we do have ways to tackle it, as we saw. So reflection, as we saw, validate and fix. We need to make sure we have good mechanism and guidelines to judge or to evaluate output of each step in the AI performs, and to make sure it only when it's good enough we can proceed to the next one. So we talked about the judge, the structured output, and or several iterations and maybe several models and options, right? And in the end, we need to make sure that each of them is validated according to automatic measures, as we saw, which is LLM as the judge, but also we need to make sure that humans are in the loop when they are needed. So there are some use cases that we should definitely loop in users and to make humans, and to make sure that we tackle this. So because it's very hard, maybe even for us humans, to evaluate that the answer is correct. So lots of measures, lots of emphasis and energy on that, and many options as we saw today.
Right. So we're going to push one more question. So answer it however you want before we run out of time here. Excuse me. How do you integrate security checks into the early stages of the agent development lifecycle without showing innovation?
So we need to do it automatically. And basically, the best, like I said, you need to have scanners for everything. So you want in the CI/CD on your GitHub repository something that automatically scan the code, scan the registry, take all the detection, and gives you only the compile it for you and gives you the findings and tell you what to do about it. So it should be automatic. It can be, we have an MCP server also, so it should be even in the IDE when you develop with Cursor or with your favorite AI code assistant. And automation, in one word. That's always the way to go.
Security native
yes.
IDE.
That's
I invented this.
We're not there.
This term.
We're not there yet. That everything would be secured, all the code.
Yeah.
All right. Well, Shuki Barel, it's been a pleasure having you. I want to thank you for taking the time to join us.